Welcome to the video on solving equations. So first we'll learn how to solve an equation with a calculator. You start by entering both sides of the equation separately into y equals, and then you'll graph and find all zeros within the domain. So for this first problem here, it says e to the x equals cosine of x, where negative 5 is less than x is less than 5. So in y equals, the first thing we'll enter is e to the x, and for y2, we'll enter the cosine of x. And then we'll hit graph. So this window is going from negative 10 to 10, but we only need to look at things between negative 5 and positive 5. Once it finishes graphing, we'll hit second, calculate, and then we'll find our intersections. So if we go over to here, we can see that this intersection is when x is negative 4.6, so that'll be within our domain. So we'll hit enter 3 times around here. So our first intersection is negative 4.72, comma 0.009. Our second intersection will be around here, so we'll hit enter 3 times. And it's at negative 1.29, comma 0.275. And finally, the third intersection is around here. We'll hit enter 3 times. And it's at negative 2.67 e to the negative 14. So that's a really, really, really small decimal. So it's essentially 0, comma 1. So those are your solutions for the first one. For the second equation, we'll clear our y equals, and we want to find when x to the fourth plus 2x minus 7 is equal to 0. So we could do a line at y equals 0 and find when the lines intersect, or we could just find our zeros. So we'll click graph. We'll go ahead and let it load, and it looks like there's 2 points where it hits the x-axis. So there are 2 points where it's going to equal 0. We'll do second calc, 0. We'll go near our first 0, left bound, right bound, enter. So it's at negative 1.80, comma 0. And we'll find our next 0. We'll do our left bound here, and our right bound here. And it's 1.43, comma 0. So those are your solutions to the second one. So the y values don't really mean anything because those are just values for the output when you put x in, but we're actually just solving for x. So for the first problem, x would be negative 4.72, negative 1.29, and 0. And for the second one, x would equal negative 1.80 or 1.43. So those would be your values of x where your equations are true. Next, we can solve equations analytically. So there are different methods for solving for the zeros. You can try factoring, completing the square, or the quadratic formula. So this first equation is e to the 2x plus 2e to the x minus 15 equals 0. So we can write this as a quadratic equation where instead of x, we have e to the x. So this is e to the x squared plus 2 times e to the x minus 15 equals 0. So we'll try doing our box where we have e to the 2x here and negative 15. So we need something that multiplies to negative 15 and adds to 2. So that's going to be a positive 5 and negative 3. And then instead of x's here, we'll have e to the x. We'll pull out our greatest common factors, which will be e to the x, negative 3, e to the x, and 5. So in factored form, this would be e to the x plus 5 times e to the x minus 3 equals 0. It will equal 0 when each component is equal to 0. So e to the x plus 5 equals 0, or e to the x minus 3 equals 0. So if e to the x equals negative 5, and then if we take the natural log of each side, we'd get that x equals the natural log of negative 5. Here we'd have e to the x equals 3, so x equals the natural log of 3. You can't have the natural log of a negative number, so our only option for x would be the natural log of 3. For the second problem, you have 2 sine x cosine x plus sine x minus 2 cosine x minus 1 equals 0. So for this one, we can try factoring by grouping because we have a sine of x in each of the first two. So you'd get sine of x times 2 cosine x plus 1. For the second part, we'll pull out a negative 1, so we'll get minus 2 cosine x plus 1 equals 0. So since these are the same, our sine of x minus 1 times 2 cosine x plus 1 equals 0. So if our sine of x minus 1 equals 0, or if our 2 cosine x plus 1 equals 0, then we can find the solution. So if sine of x equals 1, so if x equals the inverse sine of 1, or if 2 cosine x equals negative 1, so if the cosine x equals negative 1/2, so if x equals the inverse cosine of negative 1/2, then this equation would be true and we'd have a solution. So if we limit x to being between 0 and 2 pi, then x equals the inverse sine of 1 at pi over 2. So x would equal pi over 2. And x equals the inverse cosine of negative 1/2 when x is 2 pi over 3 or 4 pi over 3. So these would be your solutions to this equation. So there are several real-world examples where you would need to solve equations, some of which are radioactive decay, production's possibility curves, population growth or decay, compound interest, projectile motion, as shown here in this picture, and braking distance. So here we have our first IB practice question. It says, find the exact solution to the equation x minus 2 equals 4 over the absolute value of x plus 3. And this is no calculator. So we're going to start by getting our absolute value by itself. So we have x minus 2 equals 4 over the absolute value of x plus 3. We'll multiply both sides by the absolute value of x plus 3. So then we get the absolute value of x plus 3 times x minus 2 equals 4. Then we'll divide both sides by x minus 2. So we get the absolute value of x plus 3 equals 4 over x minus 2. Since we have the absolute value, our x plus 3 can equal positive 4 over x minus 2, or our x plus 3 can equal negative 4 over x minus 2. So we'll work on our first half first. So we'll multiply both by x minus 2. So we have x minus 2 times x plus 3 equals 4. We can distribute here to get x squared plus 3x minus 2x minus 6 equals 4. So x squared plus x minus 6 equals 4. Then we'll subtract 4 from both sides to get x squared plus x minus 10 equals 0. We can't factor this because there's nothing that multiplies to negative 10 and adds to 1. So we'll use the quadratic formula. So we have x equals negative b, so negative 1, plus or minus the square root of b squared, so 1 squared, minus 4 times a, which is 1, times c, which is negative 10, all over 2 times a, which is 1. So this is negative 1 plus or minus the square root of 1 plus 40, so 41 over 2. So our x value could be negative 1 plus or minus the square root of 41 over 2. And then for our second part of solving it, we can multiply this side by x minus 2. So we have our x minus 2 times our x plus 3 again. So that'll give us our x squared plus x minus 6 equals negative 4 this time. So we'll add 4 to both sides. So we get x squared plus x minus 2 equals 0. And this one can factor to x plus 2, x minus 1 equals 0. Because 2 times negative 1 is negative 2, and 2 minus 1 is positive 1. So x plus 2 could equal 0, or x minus 1 could equal 0. So x could be negative 2 or 1. So these are all of our possible solutions for x. When you plug those values back in, however, you'll see that x equals negative 2 won't work, because then you'll get negative 4 equals a positive 4, and x equals 1 won't work because you'll get negative 1 equals a positive 1. You also can't use the negative 1 minus the square root of 41 over 2. So your only solution is actually x equals negative 1 plus the square root of 41 over 2. The rest will be extraneous solutions, meaning that they can't actually exist. So here we have our second IB practice question where a calculator is allowed. It says the marginal cost, C, in dollars to a company for creating n 100 phones is given by the equation C equals 0.00001 x minus 85 to the fourth plus 40, and the marginal revenue, R, is given by the equation R equals 150. How many phones should the company make to maximize profit? So to find where profit is maximized, you need to find where the marginal cost and revenue curves meet. We'll start by entering our marginal cost curve into y1. So 0.00001 times x minus 85 to the fourth plus 40. And our marginal revenue will go into our y2, so 150. We're going to need to change our window because our revenue is 150, so we'll widen it to have an x max and a y max of 200. And then we'll hit graph. So our total profit is maximized when our marginal cost is equal to our marginal revenue. And we're going to want that second point where they're equal to each other. So we'll do second calc. And we'll go down to intersect. We'll move towards our second point. And then we'll hit enter 3 times. So this happens when x equals 142.6 and y equals 150. So the number of phones the company should make is when n equals 142.6, and n is hundreds of phones. So it would be 14260 because it's 14200 phones. So 14,260 phones is how many the company should make to maximize profit. In summary, to solve equations with a calculator, you enter both sides of the equation separately into y equals, and graph and find all zeros within the domain if it's equal to 0, or you find when the equations are equal to each other. The ways to solve equations analytically or by hand is you add, subtract, multiply, and divide to solve for the variable, or you move everything to one side so the equation equals 0, then try things such as factoring, completing the square, or using the quadratic formula. That's all for this video. Thank you for watching.